Hello students, in today's lecture we are going to discuss the derivation of Newton's second law of motion. First of all, we will discuss what is the Newton's second law of motion. Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to its mass. It means that acceleration produced in a body is directly proportional to the force that applied on the body, and it is inversely proportional to the mass of that body, which means if the force is greater, then the acceleration which will be produced in that body will also be greater, and if the mass of the body is greater, then the acceleration which is going to be produced in that body will be smaller. Acceleration of the object depends upon two things, force and mass. These two things directly relate to the acceleration which will be going to produce in that body. This is the equation of that law, which is F is equal to ma. Here F is the force, m is the mass of that object, and a is the acceleration which is going to be produced in that body. Now we will discuss how this law derived. First of all, our first statement was acceleration is directly proportional to the force. Second one is acceleration is inversely proportional to the mass of that object. Now, if we write them simultaneously, acceleration is directly proportional to the force and inversely proportional to the mass. Here we solve that proportionality sign. When we solve this, we will put an equation sign and also a constant where k is equal to 1. Then we ignore, so a is equal to f over m. We can also write it in other form where m will be multiplied by a, which will become f is equal to ma. It is the example of the second law where a same force is applied on a stone and mass. Where stone has smaller mass, it will produce great acceleration in that object, and car comparatively has large mass, then there will be small acceleration in the car. Hope this will be helpful to you guys.